Hi, everyone. I'm Niknas, and I'm so excited to welcome you to another AEC+tech Talk, brought to you by AEC+tech platform. So today's conversation is going to be all about sustainability, AI, and smart tools in AEC, and how technology and AI is helping us design and build more sustainable buildings. We are joined by four incredible innovators and very experienced sustainability experts from across the AEC tech landscape, each bringing a unique perspective on how their tools are addressing the environmental and operational challenges we face in the built environment. From early stage carbon modeling to performance simulation and platform integration, the tools we'll explore today each play a critical role in different phases of the design process. I'm very much looking forward to learning more about how these tools are being applied in real world projects and how they're driving meaningful change in practice. I'll start by briefly introducing our four wonderful speakers in the order they'll be presenting, and then I'll let them and invite them to talk more about their work and their experience and their tools. So first, we will have Amarpreet Singh. Amar leads OneClick LCA's US business development and brings over a decade of experience in advancing sustainability across industries. So happy to have you with us today, Amar. Thanks for joining.
Thank you.
So after Amar, we'll have Nathan Kegel. Nathan is the vice president at IES. Nathan brings over 20 years of global experience in building performance simulation, specializing in lifecycle analysis, energy and carbon savings, and technology cost benefit assessments. Wonderful to have you with us, Nathan, and thanks for your time and thanks for joining.
Thank you.
Great. So third, we'll have Cesar. Cesar Escalante is the senior technical marketing manager at Autodesk with over 12 years of experience in design technology across top firms like Gensler and HOK. Wonderful to see you, Cesar, and thanks for participating and joining.
Good to be here.
And last but not least, we'll have Jack Rusk. Jack is the CEO and co-founder of Cscale, a platform focused on whole life carbon data for building decarbonization. Great to see you, Jack, and thanks for being here. Great. So this event will be recorded and saved on the AEC+tech YouTube channel. If you have any questions for our panelists during the event, please post them in the LinkedIn or YouTube chat box, and we'll address them when we can. So welcome, everyone. And with that, I'm going to hand it over to Amar to tell us about OneClick LCA and the project and your experience and your work.
Thank you so much, Niknas, and well, welcome everybody to the session, and also hello to all my co-speakers, Jack, Cesar, and Nathan. It's great to be with you guys. So I'm going to share my screen very quickly, and Niknas, if you could let me know everything looks in order.
Yeah.
Yeah. Okay. Perfect. And so we are OneClick LCA. So we are a sustainability platform for projects and products. So we are one of the oldest life cycle assessment tools available in the market. We've been around for nearly 25 years now, headquartered in Helsinki, Finland, but we have a global presence and we have regional tools all over the world. And I'm like Niknas mentioned, part of the North America team where we have North America specific AEC and manufacturing sustainability tools. A quick note on why we're doing what we're doing. You know, as construction and manufacturing professionals, and I hope a lot of the viewers today are that, we cause nearly half of the environmental damage when compared to all the other industries present in the world. And if we look at the numbers, and I won't go deep into each of them, but almost around 50% of many different environmental lenses that you can put on, you can relate them back to the AEC industry, whether it's damage caused by creation of new products and materials and manufactured products, or whether it's whole buildings and the way they function and the amount of energy buildings use in their lifetime, etc. And having said that, on the right, you can see that we're not stopping building. We are in fact going to keep building a lot in the next decades to come. So, which is why it's super critical that as an industry, we look at things like lifecycle assessments and sustainability evaluations using all the tools that we have on the webinar today. A quick look at some of our clients. Like I mentioned, we work across both the architecture engineering side as well as on the manufacturing side of things. And you can see there's some typical names from these various industries that use OneClick LCA in their everyday workflows in order to sort of figure out what the environmental and carbon impacts of their products are. And then figuring out ways to sort of reduce those impacts using the software. It, to say anything about OneClick LCA without this image would not be possible. So this is what a life cycle assessment is. So I won't again go deep into a big lecture on LCAs or anything like that, but it's always good to remember that what we're trying to do here is analyze projects from their very conception, which is what are the products and materials that are going into each project, and where do these materials come from, where are they manufactured, how much energy or carbon or other environmental impacts does it take to bring them and to make those materials in the first place, and then all the way to end of life, going through the use stage of a building, constructing the project in the first place, and then the use stage, and then finally the end of life, what happens to buildings and materials at the end of their life cycle. So this is at the very base of it, what you're trying to do on the software when you are analyzing different kinds of projects on it. And at the same time, building material manufacturers can go on the software and do this very exercise, but for their product. So you can figure out, okay, for this kind of concrete or this kind of steel or this kind of wood, what is the life cycle impact? And those numbers then can be used to sort of figure out project level life cycle assessments. So this is what ultimately the software is intended to do. And you guys will see that this is like a general theme across today's talks, that a lot of these evaluations can be done across various different stages of a design process of a project, whether it's early phase design, project stage, and then all the way to specification and documentation. You can do LCAs at various points. But the big question is, at which point do you have the power to influence design and specification choices using environmental data? That's where the graph becomes a little distorted. So you can see that the potential to reduce CO2 emissions at an early phase of a design are much higher during the site selection and the conceptual design phase, as opposed to when you're at the construction stage, where it's not really possible for you to take decisions around, okay, can we change certain materials that we're using? Can we change certain processes that we're using on the project? And the cost of making these changes, let's say to change materials or to change design, generally speaking, in terms of the time spent and the effort required to come up with these designs in the first place, exponentially increases. So not only is it going to have lower potential to reduce CO2 at a later stage of a project, the cost of making that change is going to be very high. So the highest potential always lies at an early stage of the design process. And that's very much what the intention of the tool is, that you are able to conduct these LCA evaluations at any stage of the of your given project, and then take them all the way to documentation and submission of to necessary certifications and things like that. This is more of a pictorial representation of what those various stages and those software tools on OneClick LCA look like. So at a pre-project stage, you can do target setting. You can, we have something called Carbon Designer 3D, which is at very early stage. You can figure out that for the kind of project that we are envisioning, which could be, let's say, an office building of a certain size in a certain location using a certain frame typology and certain materials, on average, what do we expect the carbon emissions of that project to be? As a side note, we talk to so many people in the industry. Sometimes it's hard for people to make sense of carbon numbers. You tell them, this building will have X amounts of carbon per square feet, and they say, okay, but what does that mean? Is it high? Is it low? And those are the kind of questions you can answer at this early stage, where you can see, okay, looks like, conceptually speaking, on average, this building should have this much carbon per unit area, and as compared to the industry, it's probably lower or more or less. So you could find things like that, and probably at an early stage you're able to find, okay, the amount of carbon looks very high. How do we reduce it? And then as you move forward with your design process, let's say during your design stage, OneClick integrates with Autodesk Revit, with you can even upload your bill of materials, and many other sort of design tools. I know IES and then several other sort of early stage design modeling tools as well. You can have OneClick LCA plugins, get all that design data into the tool, and you are able to conduct the lifecycle assessments. And towards the later stages of the uh, of the design process, you are able to sort of analyze and create final reports and use those for your submittals. Similar to the construction, we like I said, we also work with manufacturers of building materials, and they also can, they also have sort of like a few stages that they go through in order to create EPDs or environmental product declarations for their products. So as a tool, we understand that being able to do environmental evaluations, being able to do LCAs and EPDs has a few barriers to adoption. Typically, you could categorize those barriers to adoption under 4 categories. Firstly, just the amount of LCA data that's out there in the world, and being able to really find, okay, what is the right data point to use for my project's materials and the various processes that you're using can get terribly complex, which is the second point, which is about complexity, finding the right data, finding the right calculations methodology and things like that to have a comprehensive analysis. And then the workload, the sheer amount of effort that it might end up taking someone to do all this, let's say manually, and to go one by one on each data point can be quite laborious, and it's almost like a research project in itself. And then lastly, the various standards that exist in the market, the LCAs have to be ISO compliant and certain certain things that need to be made sure that are okay with an LCA for it to be a completely verified LCA. So these are the 4 big challenges that we see in the market, and as a tool, our aim is to have all these challenges solved on the platform. So once you start using, say, OneClick LCA, you know that for sure it's compliant with specific standards. You get all possible LCA databases on the tool that you can then potentially use for your projects. And it reduces workloads because of all the various automations and capabilities within the tool to automatically take your designs and be able to conduct these evaluations on the back end. I know, Nick Naz, you mentioned that today's session also focuses a bit on AI. So I wanted to also touch upon a few things that we are trying to incorporate in terms of AI. AI is the big buzzword now, and everybody's talking about it. But I guess the question that's better asked is, what problems are you trying to solve using something like AI as opposed to just using it generally? So there are a few things that we see can be solved, using AI on the software. For example, quality data and being able to find it fast enough. Cost of creating manufacturer EPDs in general. For example, when material manufacturers make all their environmental data points, it can be a laborious process. It can take time, effort, and hence sometimes thousands of dollars in cost. So how do we automate that and bring in some AI technology there to be able to sort of take some of the details of the product manufacturing process and being able to automatically match those with existing environmental data points. And then integrations with BIM tools and with bill of materials itself, those integrations can become a lot faster, much more efficient, and much more accurate using AI and the behavior of other designers who worked on such tools before. Hence reducing the manual and labor-intensive processes, you can say, of doing these things in the first place. And then finally, AI also helps with early stage design optioneering, where you're in an early stage of the design, you're asking yourself, okay, which direction should we go if we want to reduce carbon emissions of this project? That's where AI can fit in as well. How am I doing on time, Nicknas? Do I have another minute?
Maybe a minute. Yeah, 1 more minute. If you can
Okay.
wrap up, would be great. Yeah.
Perfect. Yeah, so I'll go through these quickly. These are just screenshots of the things that I've been talking about. And of course, if someone's interested, feel free to reach out to me separately, and we can go over in much more detail with the demo. But this is a screenshot from early stage, AI generated optionalities that you can generate on the software. Then at a later stage, when you're doing data imports, identifying, classifying, and mapping materials has become a lot faster and is becoming constantly improved on the software, which is to say every possible material data point on your project can be matched with the right LCA data point. And these are all screenshots basically aiming to show that. And then even searching for materials, like, for example, this is very naive, but it in a way saying, find me a low carbon concrete in California. Now it's possible to have much more accurate results for something like that, which are based on your location, your specification, and the type of material you're looking for, rather than just a general result of a bunch of materials in your area. Lastly, I'll leave everyone with this. There's many case studies that you can find on the OneClick LCA website, but a couple that I have screenshots of here. There's Half Design, based in Canada, did a project in Toronto, and they were able to lower embodied carbon by a significant amount. And there were a few strategies, and you can find this on our website as well, on what kind of interventions they did for this specific project to be able to reduce embodied carbon. There's lower concrete carbon typologies that they use. There's hempcrete blocks that they use instead of CMU, etc. So I won't go through all of them, but an excellent case study of how people use tools like us to be able to achieve these outcomes. And similarly, Arcadis infrastructure project also achieved a 30% carbon reduction, and there were some specific strategies that they followed for doing that. And lastly, this is me, and that's the QR code that goes to me in my calendar. And if anyone's interested, feel free to reach out. Happy to have a conversation, a demo, and discuss more. And thank you. This is all for me.
Wonderful. Thanks so much, Amar, for the insightful presentation and all the great diagrams that you shared with us. So we'll get back to you with some questions at the end. Thank you. So next we'll have Nathan. Nathan, please feel free to share your screen, and let me unmute you and see. Okay.
Oops. Let's see if I can get my screen to share again.
Sure.
Can you all hear me?
Yes, we can hear you. Great.
Very good. Okay, and you can see my screen?
Yes.
Beautiful. All right, thank you, everyone. Appreciate you taking some time. It was great. I know Amara worked with some of your colleagues on the MEP 2040 Embodied Carbon and MEP Systems Beginner's Guide that was just published last week. It was really good to learn from some of the expertise there and share that. So if you're not familiar with that, it's a free guide for MEP embodied carbon. It's the first of its kind, especially for North America. So I'd encourage you, obviously that's one of my hats I wear, but I encourage you all to take a look at that. I'm going to cover today very quickly in the 10 to 12 minutes, hopefully, just kind of give you all an overview of IESVE. And we'll talk a little bit about AI at the end. And there's obviously a lot of opportunities here, but I'm going to take a little bit different tact and expand that circle a little bit because I think it's the responsible thing to do, to talk about AI, not just through the opportunities, how it can improve things, but also what some of the costs of AI are or may well be. So IESVE is the software platform. We've been doing this now in this space for over 30 years. We've been around, this is not our first rodeo. Many of you have probably heard of us or worked with us before. And the tool is flexible to be used at really any stage of the design process. So we've recently made some pretty significant enhancements on automation features for the early stages, really trying to close a lot of the loops or fill in a lot of the gaps between the architects and the engineers, especially early on. So it's, there's a lot more that goes into this than just energy and carbon. We need to make sure that our spaces meet the requirements, that they're fit for use. So we have good indoor air quality, for example, that we have the right ceiling clearances, the right light levels. There's a whole lot to this that could be assessed and analyzed. And of course, they're also interconnected. So I've kind of highlighted some of these here on different stages. And of course, a lot of this carries through. And it can get a little bit complex. The different colors are meant to identify where it would be really useful to involve not just the architects early on, but bring in the engineers to do more assessments and to provide their expertise early on. And to do that, you really need a platform that can get into some more of the details, or at least provide a little bit more confidence early on. And this kind of carries through, are very similar in nature to what Amar was talking about, of where you have the greatest impact or have the potential to have the greatest impact. And that, the paradox to that is you're often working with the most number of assumptions very early on. So it can be really difficult in some cases to develop a high degree of confidence that the results that you're getting are in fact appropriate, or in fact in the right direction, or in the right percentage of delta. So knowing how deep to go and knowing what is being required of your studies at each of these stages is certainly an art form or a craft in and of itself. And across the bottom, you can see I've kind of pulled out some of the things where AI really has the potential to help or to assist with those processes. So gathering of the information is usually a very, very onerous task. Where do you get good information from? How do you tease out the information the client is really concerned with, making sure that you're meeting their other goals and not just their sustainability goals, documenting all of that in charrettes, et cetera. So there's a lot of opportunity there, and we're working on some of these things to be able to improve, or take some of the time and some of the opportunity for error out of those sorts of tasks. Well, where we are today is really being interoperable between a lot of different design platforms. So we've partnered with a number of folks over the years, and we continue to develop these partnerships, not just in the context of continuing to build out our own tools, but we recognize that a redundant task of, say, for example, rebuilding geometry that's already built somewhere else is really not something that most people went to architecture or engineering school to do. So we've worked to be able to readily and accurately import um, uh, Revit models, Rhino models, SketchUp, et cetera, to be able to streamline that process and make that really early stage where you have a lot of assumptions, where you can test many, many, many different types of assumptions without having to spend a lot of time reworking, basic things like geometry. Enhancements to the API as well. So there's a lot of a very rich feature set for customization, in addition to being able to pick the appropriate level of input. So very high level or very detailed, and everything in between. I mentioned some of the automated enhancements. This has been in the software now for roughly a year, and it's continuing to get updated. Our next version is scheduled to have another enhancement to our parametric simulation. So this is a process whereby you can use a simple box model, to represent, really all you need to know is three things: roughly how big your project is, where the project is going to be, and what kind of project it is. In other words, is it healthcare? Is it a data center? Is it an apartment building? Once you know those three things, you can apply some reasonable assumptions based on energy code and standards, and be able to run, thousands upon thousands of combinations and permutations, and then have the software or the tool tell you, well, these are the best ones. What's unique, one of the things that's unique about this is, we're not leveraging, really energy intensive data centers uses. You can do this from your local machine. So we leverage the fact that you have multiple logical processors on your local PC, so you can spit these simulations out very quickly. We've done a lot of work to speed them up, sort of behind the scenes. And then when you find the one or the ones that are the best fit, you just promote that into back to the live full model, so that you don't have to then rework in another tool, where you're going to start again from scratch. In essence, you can just carry forward the inputs that make the most sense, and then carry on with a more detailed dive as appropriate. It's also important, in energy codes and standards, to incorporate site context. It also helps with sizing of equipment for HVAC. It helps site PV panels. So including all of that, we have tools to automatically bring in those types of adjacent structures. We have tools for automatically creating the geometry. So in other words, I mentioned, you just need to know the size. You can very quickly just tell the software to generate it rapidly for you. It will do that. And then as you carry through, there's a bunch of other wizards and parametric tools that streamline the process of, everything from transitioning from simple HVAC systems into more complex ones. Renewable energy support, including battery storage. So if we want to do a very simple early on evaluation of PV panels, solar hot water, wind energy, and the battery implications, we can do that. Shoebox modeling, carrying this more deeply and also being able to communicate more effectively with all of the stakeholders. So sometimes, the engineers will want to give you a big data table with a lot of numbers, and that may cause you to fall asleep. So we can communicate that in much more visually interesting ways. So here, for example, we have a space where we're looking at shades. no shades and shades and varying the wind to wall ratio. And what we can see is that we've cut the peak cooling capacity or the peak cooling requirement from 1.4 CFM per square foot to 0.7. So in other words, we've halved the size of the HVAC system serving that zone. Daylight designs, we support all of the Illuminating Engineering Society metrics, spatial daylight autonomy, et cetera. You can use this for the likes of submitting to LEED under version 4 and onwards. Natural ventilation, mixed mode, CFDs included for doing detailed airflow, indoor air quality studies, indoor environmental quality studies, all of those sorts of things. We use the heat balance method for all of our loads, including the hourly simulation load. So we're getting a very accurate load. For those of you who may be a little bit more technically inclined, if you don't use the heat balance method for like doing an hourly load calculation, you're not practicing good fundamentals. That's not much. Don't take my word for it. That comes directly from the ASHRAE Handbook of Fundamentals, where only an hourly heat balance load calculation, or only the heat balance method is suitable for an hourly load calculation. Um, Airside systems, we've created lots of different prototype systems over the years. We continue to enhance this. We continue to build out more and more heat pump capabilities so we can move heat in a lot of different ways, combine a lot of different heat pump systems, do simultaneous heating and cooling, size these systems based on a heating load or a cooling load or some combination thereof. Outputs in a lot of different categories to automate creating equipment schedules or airflow schedules within other design tools. Again, automating the QA or QC process, streamlining that with visuals. And of course, we still have the standardized, if you want to call them that, loads reports that many people are accustomed to seeing. So really trying to talk to everybody that's involved in the design process and help everybody have a common understanding of the decisions that are being made. When necessary, to go deeper into the individual components, so beyond the room level or the building level, digging into heating and cooling coils, fans, chillers, boilers, etc. Understanding the water and energy nexus, whereby when we consume energy, there's usually a water penalty associated with that. So our software will allow you to estimate how much water you can potentially capture off of a cooling coil, how much water a cooling tower may consume on an annual basis. So not ignoring the water question. So before I jump into some of the AI stuff, we do a monthly web demo. They're always free. You can sign up there. Typical demo takes about 60 minutes. However, you may want a more specific demo for your organization, AKA if you're an architect and you don't want to, really care about all of the engineering stuff, or the inverse may be true. You can always reach out to myself directly, and I'll be able to schedule that for you. So really quickly in the last couple of minutes here, AI is certainly something that is disrupting a lot of what we do on a daily basis, and we're excited about some of the opportunities that are out there and exist. I kind of touched on a few of those, but I think it's irresponsible to not talk about the other impacts that AI is having, and namely the environmental impacts and also other impacts on society. So we can't just think about this in our narrow little sliver, because it is such a revolutionary, like something we've really never encountered before in terms of the technological breakthroughs. So I I personally follow a lot of this. There's some concern here because recently, this was published on Wednesday, that AI is 6 times more persuasive than the average human comment. So I think that is a very huge risk when you start talking about, should we trust what AI is telling us or not. It can certainly be more persuasive, for better or for good. One of the things that I think this group probably is most in tune with is the environmental impact. I mean, I've worked in this space for over 2 decades trying to minimize the environmental impact of buildings, and data centers are hugely environmentally impactful. They consume crazy amounts of energy. According to Kate Crawford, currently AI is consuming, it'd be the 5th largest country. If it were a country, it'd use the 5th largest amount of energy of any country on Earth. And we continue to build out data centers to support more and more AI. So it's just some rough kind of translating that of what that means. It is estimated that training GPT-4o consumed about 65,000 megawatt hours of electricity, which is enough to power 12.1 million US homes for 1 hour. Using AI or Chat GPT is roughly 10 times more energy intensive than just using a Google search. One study found that the amount of water that it's consuming is it will be very soon 4 to 6 times the water consumption of the entire country of Denmark. And when it comes to embodied carbon and waste, only about 0.25% of the materials that are harvested actually end up being used. So it is a serious AI. Data centers, AI has a huge environmental impact that I think we need to include in that conversation. So that's I can go on, but I'm out of time, so I'm just going to skip there and appreciate it very much, and I'll turn it over to the next person.
Wow, thank you so much, Nathan. Thanks for the great presentation. Thanks for all you've done for the industry, and thanks for all this data at the end. Oh my gosh, next time I'm gonna ask ChatGPT a question. I give it a second thought. Wow, thank you. So we'll get back to you with some questions at the end. Okay, so we have Cesar next. So let me turn on your screen, Cesar. Okay, hand it to
you. All right. Hi, everyone. My name is Cesar Escalante, Technical Marketing Manager at Autodesk, focusing exposing the innovation coming out of our pipeline for architects and the AEC industry. There's a QR code there if you want to connect with me via LinkedIn. So today I'm here to talk about what's new in sustainability, and I have picked features that are both addressing new capabilities based on that support automation, and then are powered by AI. And there are 4 of them that I'm going to display. First one is the integration of Recap Pro with Revit through the incorporation of Point Fusion, which is an acquisition that Autodesk did a couple of years ago, and now it's seamlessly integrated with the Revit environment. Second, I'm going to talk about how we, in 2026, enhance system zones and enabling the ability to connect quickly with Autodesk Insight, which is our sustainability tool, integrated with BIM. I'm going to talk about a few changes and new innovations around Insight for Revit, and new AI-powered Forma capabilities like the site automation, combination with rapid analysis, new features supporting embodied carbon in Forma, and a couple of new integrations, the OneClick LCA, which was presented earlier in this presentation, and lastly, a generative design tool called Finch. Look quickly, Autodesk has a whole array of solutions that support sustainability goals across the life cycle. On the screen, you have what is readily available in the market, from Forma at the early stage design, to Revit system analysis in the design development, and an integration of takeoff and EC3 within construction, with plans to integrate the data more in the pipeline and offer facility management and operation tools in the near future. The first thing I want to present is our Recap Pro plugin for Revit that enables direct integration to scan to mesh point cloud data into Revit, allowing you to convert 3D scans and photography from existing buildings into segmented meshes, and convert those segmented portions into Revit families without heavy manual modeling. This streamlined scan-to-mesh BIM workflow is crucial for sustainability because it accelerates the retrofitting and adaptive reuse goals of the industry. Let's take a look how it works. So here is a scan mesh inside Autodesk Recap. So using this new workflow, you can extract the information you need from a mesh that is generated from a point cloud. So once this mesh is created, utilizing local processing power, you can open and edit the mesh using our mesh editor. And then you can select and classify these objects in different type of layers. Once this feature is selected, you can create new classifications. You can apply data and assign the different segments to different target layers. Once you classify all these elements, you repeat the process from system to system. Now, if you're part of the collection, these will come out of this extension will be automatically installed in Revit 2026. The Recap Mesh plugin allow you to import mesh objects, and inside the Revit environment, you have the ability to convert the segmented layers into Revit families, allowing you to expedite the scan to BIM process. It was recently announced. It's less than 2 months in the market, so take advantage of it. Another thing, more on the mechanical side of Revit 2026, is the ability to create flexible zones. And so for those who are in the mechanical area, in previous version, we have a separation between spaces and zones, and now we have combined them. And these allow us to be more flexible in the use of the data that happen between these instances. The new system zones allow you to report properties like occupied area, energy set points, that are utilized to more accurately measure energy and carbon analysis. Let's take a very quick peek at how it works. System zones can be created via sketch, or you can pick existing rooms independently from architectural elements. And these zones support properties like I was mentioned earlier, energy set points, outdoor air rate, occupied area, that are associated with cooling, heating, and dehumidification processes, and allow you to schedule it. It also support IFC capabilities for improving interoperability with systems that are not coming from the Autodesk ecosystem. We believe that this upgrade is critical for sustainability goals because it enable more precise modeling over the control of environmental systems, and it facilitate accurate energy use, carbon emission assessments, and the calculation of operational carbon. By integrating these enhanced zones with the next generation insight, you can better evaluate and optimize the use of energy and carbon in your projects and get you closer to achieve your sustainability goals. And speaking of insight, we're not familiar with insight, is our energy analysis and carbon analysis tool integrated with Revit. It used to be a standalone plugin, but now it started in 2025. It's integrated with your Revit installation. A big announcement this year is that Autodesk is phasing out the old energy analysis engine, which was Green Building Studio, and we're launching the next generation of Insight Carbon. So this started in April 2nd, 2025. You won't be able to use the old Green Building Studio analytical engine. And the new Insight Carbon Analysis, which is integrated from Revit 23 forward, will enable you to evaluate both the embodied carbon in your project. Let's take a look at how it works. Oh, one specific feature that I think it would be interesting for this crowd is the ability to automatically report carbon emissions into the AIA 2030 DXD reporting. You can access the reporting tool in the user interface directly in Revit. This is going to automatically fill your credentials, allowing you to selectively pick the fields that are mandatory by the AIA reporting. You can also add additional information as needed. And then you can configure the analysis, and check all the inputs required for properly reporting this with the AIA 2030, and connect directly the project with the database without the need of adding additional spreadsheets or doing manual connections. So this was announced a couple of quarters ago, and we're going to be running a demonstration of how this tool works at the AIA convention coming up in June. So if you are at the AIA conference, please stop by our booth. All right, this is another tool that was re-engineered in a couple last quarter. We are reintroducing the site automation, formerly called Forma Explorer. It's a generative design tool that enables a rapid exploration of multiple site layouts to measure site capacity early in the design process. When you couple this with the advanced 3D modeling, it allows you to very quickly create rapid scenarios on building capacities informed by AI-based analysis. Let's take a quick look on how this works. So site automation, which is now offered in Autodesk Forma, allow you to explore generative design solutions and explore capacities in a couple of clicks. You're able to generate multiple building solutions and circulation layouts utilizing a selected site boundary. And you can start pretty simple. You create a layout, explore diverse type of typologies. The options available are city blocks, line buildings, towers. You can use different mixed configurations for different zones. And then once you are closer to a solution that you like, you can refine it by adjusting parameters like number of floors, stories, width. The tool allows you to manipulate the edges and vertices of the presented layout, and it's reporting live metrics as you interact with the proposal. And at the same time, you can combine it with the rapid analysis provided by Forma, like wind and microclimate, to get direct feedback. To take it to the next level, you can unlock the different pieces of massing and use the 3D sketch to take the buildings to the next level. We believe that this provides architects and designers with very quick assessments of site feasibility studies informed by environmental analysis. So it's readily available to you. Please feel free to check it out. And speaking of, I'm going to be delivering a webinar about this on May the 8th. There's a QR code if you want to sign up for that webinar. It's only 30 minutes. It will be live stream. This is another one that we've been working on for probably about a year. We launched our embodied carbon analysis in Forma in partnership with Cscale. And Jack is going to talk more about that after my presentation. So basically, we create a machine learning predictive engine that estimates carbon emissions from early stage design. Our goal was to create something that was readily accessible to the users and that helped understand what are the carbon impacts based on assumptions on the building structure, finishes, and mechanical systems. Let's take a look at how it works. And it's pretty simple. We start by drawing a very simple drawing, a very simple building. We define few properties, like what is the program, what is the primary structural system, what is the cladding material. Then we run the analysis, and we have a color-coded analysis of the contribution of the different building systems into the emissions. So within seconds, you can have you can visualize the results, not only one building but all the buildings on the site, and see on the right panel how the different contributions of the different systems impact the total reading. You can also customize the values of the baseline emissions and customize it to your use case. And recently, this is going to happen in the next couple of weeks, so this is a preview of what it's coming, is the ability to run carbon analysis to imported OBJs. We're excited about these capabilities. I think you can basically start your massing environment outside of Forma if Revit is your primary way of modeling, or SketchUp or AutoCAD, and just bring it into the Revit environment and run the analysis and get a preliminary reading on what the carbon analysis might look like.
Thank you so much, Cesar. This is very exciting and interesting. Do you think you can please wrap up in a minute? Unfortunately, we're running out of time.
One more feature. We have an integration with OneClick LCA, and we already talked about that. And then finally, we have announced an integration with Finch. Finch allows us to streamline the early design stage process by combining the analytical powers of Forma and the AI automatic layouts from Finch. We're very excited about this technology, and we will be also featuring forthcoming webinar hosted by Finch on May 13th. So stay tuned for that. And I think with that, I wrap up what's new on our end. And I'll hand the stage to Jack.
Amazing. Thanks so much. I love all these collaborations and integrations between all these great, powerful tools. It's truly like empowering the industry. And I love all those features that you showed. You know, on AEC+tech, we get demo requests and inquiries like requests every day. And two of the most popular ones are site analysis and actually site planning tools. So I loved it that Forma now has this like site planning feature and also energy modeling tools. So thanks for sharing, Cesar. Next we'll have Jack with Cscale.
Thank you, Nicknaz. The time being what it is, how long, how much, how should I size my presentation?
Yeah, please feel free to go for your 10 minutes, and then if you all agree, we can stay for 5 more minutes and address some of the questions.
Sounds good. I'll share my screen. Awesome. You should be seeing my screen now.
Yes.
Really happy to be here with y'all. Jack Rusk, Cscale. We build whole life carbon tools for architects and engineers, and our goal in the industry is move projects and practitioners who would not otherwise be doing this analysis into a position where they can contribute to climate solutions. The decisions made by engineers, architects, designers, and planners every day literally move mountains. The networks of resource extraction and material movement globally, right, happen at the stroke of a pen or the drawing of a line, right, in the design documents. And these small choices that we make have really far-reaching material consequences for the social world globally, as well as the ecological world. So just like our decisions we make can contribute to negative outcomes through these supply chains, we can also make positive decisions, investing in regenerative choices while also minimizing the use of scarce resources and even, you know, bio-based solutions that might have land use impacts that outstrip maybe some of their climate benefits. We see life cycle assessment, and really specifically whole life carbon assessment, as the tools that allow any given practitioner to tell the difference between negative outcomes and positive outcomes from the choices they make day to day. One thing that I think is always really important to remember in this discussion, again, is that designers have a purchasing power and therefore a power in their decision making orders of magnitude higher than an average consumer. So I might make the choice this year or for my entire lifeline, say, to eat a vegan diet or only bike to work. But the decisions, a person might make detailing a shade assembly or designing a curtain wall can have, in just the way that detail gets drawn, many lifetimes of positive impact in the way it's able to reduce material use and supply chain emissions. And this really, I think, is an important thing that we as an industry need to hold on to, is the power that we have in the decision making we make every day to shape these decisions. We see, though, in the sort of current landscape of solutions available, tools will say that are sometimes described as needing multiple engineering degrees to even get started, right? And we really are looking towards building workflows that allow designers and people who are not otherwise lifecycle assessment practitioners to participate in these decisions and improve building outcomes through the use of data. We do this by establishing reasonable guardrails, building analysis parameters that reflect the real world, not an idealized world, and by packaging all of this into easy-to-use user interfaces, used especially these days actually in higher education as teaching tools to help the next generation of practitioners become fluent in low-carbon design. We see this as a really important mechanism towards scaling these practices for the next generation of designers in the industry. So taking a whole life carbon approach also means looking at a very wide solution set, balancing operational carbon with embodied carbon, looking at landscape effects and refrigerant leakage. We're seeing in certifications like LEED v5 the move towards a whole life carbon approach. And we feel like this is essential to avoid some of the burden shifting that happens when people are working in silos, only looking at embodied carbon or only looking at energy use, and really trying to build tools to bring these together so that the people making decisions can do so with the full decision environment in mind. We've been working with designers globally on these tools, and it's been really a joy actually to work with these firms. If there's anybody from these firms on this call, hello, great to see you. In addition to all the firms we're working with, we've been really happy to support Autodesk in deploying the Cscale model as a native integration within Autodesk Forma. We also work with large equipment manufacturers like Schneider and real estate trusts like Galvanize, all towards the purpose of scaling their climate impact globally. So many workflow tools that you see in the industry have this sort of like simplistic conception of projects as this linear flow from concept design through construction administration. We learned this in architecture school, but then as soon as you get into practice, you realize that the reality of projects is much more complex and much messier. And you see that many of the ways that the McLeamy curve is drawn, it really is this nice march from left to right. But the reality of projects is that they're much less linear processes. You design to a point, you value engineer back. You design the structural system all the way through to detailed drawings. But the interiors are still, like barely sketches and look and feel boards. So really trying to balance these different level of resolutions and this, we'll say, non-linear process that most projects are subject to is really what we're focusing on at Cscale, is building tools to support the messiness of real projects. We do this by moving across many levels of resolution, and very crucially, trying to work across levels of resolution, especially when data is available at differing levels of resolution. It's very often that you'll have a very detailed structure and enclosure module, but site and interiors will lag. Or you'll know so much about, like if you're doing workplace, about the look and feel and the materials used, but there's an MEP upgrade floating around the edges that you don't know that much about. So the ability to work in different categories and different levels of resolution to ensure that at every phase you're making good decisions, this is really what we're excited to support across all these firms at Cscale. Because the reality is that current tools are often built to highlight decisions at later phases once data is available. We've been really working for the last 5 years to move decisions left by filling in predicted data along the way so that designers can make directionally accurate decisions. And we've been really excited to see these approaches to highlight earlier whole life carbon decision making catch on across the industry. And I think that's really highlighted by some of our collaboration with Autodesk and Schneider Electric and other firms across the space. So early phase decisions, you know, Amar said this, Cesar said this, Nathan said this, is obviously really where the you know, the sweet spot is in terms of influencing outcomes, but it's also in the least data is available. And that's why us, like others, are using data-driven approaches to do this. We're really, there's another talk to give that's much more in the weeds about how we build our kind of data infrastructure. We're really big fans of what we call small models. So not big transformer models, but very efficient GBM and SVM models and the orchestration across many versions of those instances to build model pipelines that can make reasonable predictions even when data is scarce. And this is something we've been really refining, not only in terms of how these models predict things like quantity data before the building is designed, but also how to run them very efficiently so that we can run them on CPUs instead of GPUs. You know, there's a lot of, we'll say, like natural language processing happen now, where you might accidentally ask a AEC specific chatbot how to bake a pie, and it'll give you instructions for, you know, how to make an apple pie. This shows that like some of these tools are leveraging resources that are not scaled properly to the question at hand, leading to resource overruns upstream, you know, in data centers, et cetera, as Nathan has illustrated. I think there's really something important when we talk about machine learning and the use of like these data science approaches to find the right tool for the right job, right? Which often means we're not using general purpose models, again, because the resource consumption, et cetera, is sort of off the scale. With this, one thing we're really excited about, I think Nathan highlighted this really well in his presentation about IES as well, is supporting scenario-based decision-making, the ability to look across many options, find what's best, evaluate trade-offs and differences between ways of approaching a project, because this is really like what it comes down to in the end. Like the designers are often interested, we'll say, in what the carbon number is for a project. This is important for reporting and compliance. But when you're really trying to make a decision, you care less about what the number is and more about the difference between two numbers and how those numbers change over time and the trends in the data and the patterns. And this is really an exciting space, I think, to be in generally in data science, because it requires really like a thinking on the margins and sort of a thinking in the first derivative, right? You're less concerned about just getting the number right, but more about getting the number right and how it changes to ensure that the decisions you're supporting are directionally accurate, even if the order of magnitude is uncertain because you're at earlier design phases. As mentioned previously, we've been really excited to work with the team at Forma. I think there's a lot of ways that we are thinking about the resolution of models and the way that people move through design phases forwards and backwards that gives us a lot of like nice overlap. And it's been a really, really kind of inspiring collaboration with the team at Autodesk. So with that, I know I've been speed running through this presentation. I'll stop there. Thank you all so much for sticking around till the end to hear this.
Wonderful. Thanks so much, Jack. Let me turn the screen off. So we actually started a little late. So thanks for staying a few minutes more, 5 minutes. We are missing Amar. So I have a quick question for all of you. I would love to know, and I'm sure our audience would love to know, Jack mentioned some of the companies, I know that maybe some of you are not directly working with clients and users of your products, but most of you know. What is the main challenge of users? So the first part of my question is this, who is using your product? Architects, engineers, contractors. So you mentioned the phase of the design and the specialties. So, and what's their biggest challenge when adopting your tools and technologies and platforms? So if you can each tell me in a minute and a half would be amazing. We can start from Jack actually and go Jack, Nathan and Cesar.
Totally. So I do a lot of direct work with project teams. I was actually just fielding questions from some friends at Arup yesterday and earlier today. I think that sort of engagement is really productive for us. So if anybody on the call has questions, really happy to dive into specifics. You have my email address. We do a lot of work with architects and engineers. We do work with owners. I work with Galvanized Climate Solution, right? They're a real estate investment trust. We do work with product manufacturers like Schneider Electric. There's a lot of convergence, I think, in the questions and claims that people are interested in related to sustainability and climate and the built environment. And we work, and our data models work sort of across these use cases to try to find solutions for everyone.
Oh, apologies, Amar. Okay, wonderful. So, Amar, would you like to go next? And then we'll go to Nathan.
Yeah, absolutely. So like I mentioned, we work across the architecture, engineering industries, as well as manufacturing. Most of our users also tend to be architects, engineers, and depending on the size of the firm, sometimes they have specific folks doing sustainability and things of that nature. Sometimes it's designers themselves who do it. Sometimes for boutique firms, it's literally everybody who's also doing this and 1,000 other things on a daily basis. And as Jack mentioned, it's the realities of projects being much more messier than otherwise perceived. On the manufacturing side, things are evolving quite a bit because the EPD requirements around the world are rapidly changing, and larger manufacturers are now also incorporating sustainability positions, and people specifically looking at the impacts of their products and how to change those. Generally, they tend to be technical people who have big expertise in that specific kind of material and the material science that goes behind those. In terms of challenges, it's pretty much, sometimes the tools are super new for the firm, and there's a bit of a period where it takes a bit of time to get people completely on board in terms of really convincing them this is worth the time and the effort that they have to additionally spend in getting trained and things of that nature. But I guess that's true for every new initiative and tool in life. So, but I won't take up much longer than that, but pass it to Nathan. Yeah.
Thank you. That was very helpful.
Yeah, very
Nathan.
similar. We work with really everybody in this space. So we work with a lot of architects, engineers, contractors, manufacturers, other software developers, and other partners throughout industry. So I think it's a really exciting space to be in. Having been doing this sort of work for a long time, I think the challenges really haven't changed that much. I think some of the things that make it a bit sort of easier to get your toe dipped into the water still only get your toe dipped into the water, and really the learning that I think a lot of what we try to do is to impart our knowledge outside of the software. So learning the software is one piece, and that's relatively simple. I think for most software tools, that part's relatively simple. But learning that you can trust the results, or learning that just because you got an EUI of 20 and the difference is 4 is not the same thing if the EUI is 40 and the difference is 8. Like, those are not equivalencies, even though mathematically they might be. So it's that sort of practical knowledge, if you will, or wisdom that needs to somehow be imparted beyond just the pretty picture or the number and all of those things you get on the screen. So I think for a lot of our customers, that's their biggest challenge. So we really spend a lot of time, Jack was just mentioning, I'm on the phone every day, nearly every day, with somebody, helping them solve or helping them understand what they're looking at and providing that appropriate context.
Amazing. Thanks so much, Cesar.
Well, Autodesk has been in business for 40 years, and we serve the entire life cycle of design. We have traditionally supported the design process since the inception of the company. I would say that, more recently, in particular, from the time we decided to embrace cloud technology, we understand the need of supporting the industry by opening our ecosystem to third-party developments. And although the vision is still there, I think one of the major frictions is how to preserve and open the gates of data flows between different tools seamlessly without compromising and open data, the risk of data loss. I think that's it's going to take a few years to mature the technology to make sure that data is appropriately packed and streamed, not only between Autodesk products, which is a combination of grandfather desktop products, new next gen cloud technology, but also with important partners in the ecosystem, and making sure that the friction is reduced. And so we hope that that friction is reduced shortly by creating better interoperability tools and improving the connection workflows.
Wonderful. Thank you so much. We have multiple questions from our audience, but unfortunately, I would like to respect your time. Unfortunately, we don't have time to address them. So, dear audience, please feel free to reach out to our speakers directly and ask your questions. So, with that, I'm going to wrap up. Thank you. Thanks to our speakers again for giving us your time and sharing your expertise and insights and telling us more about your tools and platforms. So we all got even more excited and more hopeful about the role of innovation and all the wonderful products you are building in a more sustainable and better future. So this video will be recorded on our AEC+tech YouTube channel. Thank you all again and have a wonderful rest of your day.
Thank you.
Thank you so much. Thank you, Nicholas.
Thank y'all.
Bye-bye.